Hi, my name is Iesha. Today I will be showing you a problem about a Junebug sitting on a hill. A Junebug on a hill? What is that? Well, let me ask you a question. Have you ever seen a car sliding down a hill? Well, now you have. So today we'll look at an opposing scenario. Imagine yourself sitting in a car, and this is a Volkswagen yellow bug that you named Junebug. On a beautiful sunny summer day, you're driving up this green hill and you look to your left and you see a beautiful sunset nestled in the clouds. And you think And you think to yourself, how on earth does this car move at a constant speed up the hill without sliding down the hill a bit for me to be able to enjoy this scenario? Well, maybe you've never thought that, but a nerd like I am, I think about this all the time and like to tell you more about it. But first, we need to review the 3 laws of Newton's laws of motion. Remember Newton? The dude that was sitting under the tree one day, an apple falls on his head and he went ding ding ding, came up with 3 ideas. Number 1, the sum of forces in direction and in magnitude must equal to 0 when it's exerted on an object for the object to be moving forward at a constant speed or at rest. Number 2, force exerted on an object equals to mass times acceleration. Number 3, forces exerted on an object, the object would exert back in opposition another force of the same magnitude. So that's why don't go about hitting anyone, because you would just be hitting yourself. Alright, let's take a closer look at the Junebug on the hill. You would say, yeah, duh, the Junebug would slide down the hill because it has a weight. The weight would pull it down the hill. But at the same time, there's also a pulling force of the engine that causes the Junebug to be able to move up instead. And don't forget, Mother Nature is also supporting the Junebug above the ground instead of sinking into the hill. Let's take a closer look at how to evaluate these 3 forces. But first of all, let's look at the weight. Weight is easy, you would say. Weight equals the mg, mass times gravitational acceleration, which is 9.8 meters per square. Correct. And on a flat ground, that's all we're concerned about. But when you're on a hill with an angle of alpha, it gets slightly more complicated. If we look from the perspective of the hill, we can see that weight is pointing towards the center of the earth, but it is at an angle. The angle is coincidentally also alpha. If you're really good at math, you would say, oh, so we can dissect weight into 2 components, an x component that is parallel to the hill, and a y component that is perpendicular to the hill. The y component is w times cosine of alpha, which is equal to mg times cosine of alpha, and x component would be w sine of alpha, which is mg times sine of alpha. If by any chance you have trouble understanding how it came about to these, feel free to text me or email me and I will explain it to you in greater detail. But for the sake of time today, we will be moving on by taking a closer look at this Junebug on the hill. Yellow block on a hill, my lazy version of Junebug now. Weight is mg. Perpendicular to the hill is the cosine component of the weight, mg times cosine of alpha, and parallel is mg sine of alpha. Now remember these 2 closely because we're about to look at them separately. Okay? Look at this component that is pointing down and parallel to the hill. That is clearly the component that causes the car to slide down the hill. Remember? mg sine of alpha is its value, so therefore we need a force, which is the pulling force of the engine, of mg sine of alpha for the car to be at rest or moving up the hill at a constant speed. Yeah? Now, don't forget, the earth is also supporting our car with a force of n. What is that? Well, remember, the car is exerting a force of mg times cosine of alpha pointing perpendicular directly into the hill. In order for it not to sink into the hill is exerting a force according to Newton's law number 3, n opposite in direction and equal in magnitude, which is mg times cosine of alpha. Ta-da! Here we have the summary here. Therefore, all three forces being evaluated here. The car moving up the hill has a weight that tends to pull it down with a magnitude of m times g, mass times gravitational acceleration. The engine is pulling the car up with a force of mg times sine of alpha. The earth is supporting the car with a force of mg times cosine of alpha. I put these purple lines around. You don't need to do that during your test or your homeworks, but I want to remind you that we are most of the time interested in the magnitude or value of these forces, so they're always positive. But in reality, these forces are pointing at different directions. Therefore, if we take into account of the direction of these forces, the sum of these forces equals to 0 for the car to be at rest or moving at a constant speed. But again, for the sake of your exams, of your homeworks, we are calculating the magnitude of the forces. Just keep in mind with this diagram and the directions of the forces. That's it for today. You did great. And tomorrow, we're going to talk about how this Mini Cooper redeems itself by moving up the hill in acceleration, and how that looks on a diagram in the laws of physics. Thank you, and feel free to email me or text me with any questions. Bye!